Okay, so hello everyone once again. And our next guest came here all the way from Poland. And probably this will be a part of the conference for the non-managers. And we have a lot of these people, so I hope you enjoy it. You're going to enjoy it. So let's give the floor to our guest, Mariusz.
There will be even some code. So be ready for this. Okay, we're going to talk about refactoring, but one, two, one. Okay, about refactoring, but more about the process done. There are some problems here. One, two, three. One, two, three. We'll talk more about the process than the techniques itself. But before we begin, I would like to learn something about you. So, who of you have ever heard a word refactoring before? Please raise your hands. Oh, I think that most of you. Okay. So who of you have ever done at least one refactoring in your life? Please. Still almost everybody. Who does the refactoring from time to time? Please please raise your hand. About half a room. Okay, and who does the refactoring every day? Still quite a lot. I think about 20%. So it's good because this is not a stuff for the beginners, and there's some kind of a supposition that you know something about refactoring, that you have some experience with refactoring. But before we begin, again, I would like to energize you a little bit, and I don't know whether you knew that refactoring is like sex. Did you know that? Pardon? When it's bad, it's still good. Okay, that's a very good thing. Maybe other ideas why refactoring can be like sex. Size doesn't matter. Yeah, I like it. Okay, another ideas? It's done by billion people every day. Okay, that's good. It's never enough. Yeah. Okay, a little bit further. Okay. Result is unexpected. Yes, great. Any other ideas? Yes, sometimes it can have bad consequences. Okay, I had a few ideas, but I think that we covered a lot of them. Once you get started, you only stop because you are exhausted. Are you familiar with that? Yeah? One mistake and the consequences may be really huge. People more talk about it than actually do. And you can do it for money or for fun. Who does this for money? Yeah, I used to. It's not really an appropriate topic for dinner conversation. Have you ever tried? Okay. It will be more technical talk, but there's also something about working with managers. I want to show you some kind of experiment that I do with business people in order to make them aware why refactoring can be important. I don't want to I don't want to tell you that it always works, but sometimes it's helpful. Okay, you will see the text on the next slide. And your task, your goal will be to find an answer to the question in this text. And the answer will be written at the top. So there will be text, and the question is at the top. And now you have maybe 1 minute to find an answer for this question. But don't try to guess. I would like to find this answer here. Why is it difficult to understand software after some time of its evolution? Okay. Any ideas? Mess. Have you found it here in the text? Okay. Maybe this version will be easier. So, do you have an answer from the text? It's too difficult to find. What? You need pictures, not text. Okay. Okay. I think that the answer is obvious. The number of dependencies and interactions increase. And of course, the text is just some kind of visualization. It's kind of an example. Why do we need refactoring? Because when we work with a system like this, it's very difficult to find answers even for easy questions. When these questions may be very easy to answer when we have this kind of code, this kind of text. And this kind of experiment I try to do sometimes with business people, depending on relationships. And sometimes it's a kind of, now we more understand why you want to do it. Of course, we have to be honest that refactoring is not a business problem. This is our problem, programmers' problem. And many times I can hear that teams don't have time for refactoring. And you know, we can argue, because I like to divide refactoring in two types of refactoring. One type of refactoring is everyday refactoring, and the other one is strategic refactoring. When I think about everyday refactoring, I think about some changes that are within the reach of a single programmer, that can be done in minutes, that are mostly safe, especially in languages like Java, C# or similar languages. The changes that are local. And this is something that should be really a part of our programming practice, that there is no excuse for not doing it. What's in here? Cleaning names, naming conditions, extraction methods, moving methods. So quite simple refactorings that do not change the structure of the system. And this is everyday refactoring. And strategic refactoring is something that it's more a team effort than a single person effort. That it requires something that requires planning, that especially in bigger systems cannot be done just ad hoc. It generates items in the backlog. Yes, this is a position in our planning. Many times it's a risky activity, so it involves additional testing, not only automated testing, but also user acceptance testing. It's difficult and time-consuming, so we should be very sure that we want to do that kind of refactoring. Not only we have to convince the business, but we have to convince ourselves that it's really worth, because we can spend a lot of time here and gain almost nothing. So what kind of practices are here? Higher level design patterns or architectural changes. So this kind of things are more strategic, that requires planning. So this should be done carefully. How to get more sure that it's really worth to do strategic refactoring? Of course, there is no golden rule, but it's a helpful tool that I want to show you that is based on cyclomatic complexity metric that this tool was invented, described by Michael Feathers. Maybe you know his book, Working with Legacy Code. And his suggestion is the following. Let's take a look at the code in 2 dimensions. One dimension is how complex is your code? How complex are your methods in the particular classes? And another dimension is how often it changes. So we look in a repository, half a year back, maybe a year back, depending on the scale of the project and the age of the project. And we take a look at the information, how many times it changed. And having this 2 dimension, we can divide our code in 4 types of code. One type of code is high complexity and seldom changes. So we have mostly badly written code, but it's stable. Many times it's a core of a system. And because it's stable, doesn't change too much, in most cases, there's no need to do anything about it. Just leave it. We have to live with it, even if we don't like it, even if it's big ball of math or spaghetti code. Another part of code is where we have low complexity and seldom changes. So we have some quite simple classes, some quite simple methods like utils or similar things. And of course, this is something that we don't need to change, we don't need to refactoring. Another type of code is when we have a low complexity and frequent changes. And this is our heaven. Yes, something that we work very often with, and it's well written, it's not complex. And the most interesting part, especially in case of refactoring, is the last one, when we have a high complexity code and it changes very often. It means that we lose a lot of time as a team or many teams in this part of code. And this is something that is worth considering to refactor. Of course, still we don't have a clear answer what really to do with this code. But there are many architectural approaches that can help us. We'll not talk deeper about it here. Okay, this was a kind of a background. But what is the natural course of refactoring? As I said before, it's a kind of a process. I work with teams. I do not work in one company, but work with many teams. And I have done in my life many initiatives that were about doing big refactorings. And I also do the trainings about refactoring design patterns. And combining these two things, after many experiences, I started to figure out that there are some repeatable steps, some repeatable things that we do very often. And I started to, how can we model this? Maybe it may be helpful to have it more clear, maybe visualized in some way. And this is what the natural course of refactoring is. It's a process of the steps that are usually done, single small steps, so that we can improve our code constantly. And there are many steps. So we start from the point where we have a code, legacy code, that is badly written. So we have maybe 200, 300, 400, or maybe more 100 lines of code, and we want to do something about it. And the first thing what we can do in this situation is try to figure out, to understand a little bit what's going on in this code. Many times it's the most difficult part of the process. When we do these things, let's try at the beginning find an author and try to get some information from him. Of course, many times author is not available. Doesn't work in the company. Maybe you can find somebody else who worked with this code. And as a last thing, try to do it yourself, by yourself. It's always time-consuming, and do it by yourself from the beginning is always very time-consuming. So you should do it as a last thing. This is the last possibility. What can you do in this part? You can clean up the names. You can add some temporary comments. I will show you some kind of comments that can be helpful. Introduce lazy variables initialization. Make optical cleanup. Make something that is called scaffolding or scratch refactoring. What is scratch refactoring? You get the code, you copy it to the notepad or something like this, and try to do some refactorings just for a try. The most likely you will abandon these changes, but it's just to get more familiar with the code. Okay. What are those temporary comments? When you read the code and you have, for example, 200, 300, 400 lines, it's not possible that you will remember everything. So it's good to take some notes. And these comments are kind of notes. When you see something you don't like, write smell and what you don't like. When you have an idea what to do, write the comment refactor and express your idea. When you read some piece of code and you understood what is going on, just add the note. The prefix here is important because there may be some comments in the code. So when you write at the beginning of the note, you will know that this is your comment and not the original one. And the last one may be helpful from time to time. You have some idea, but that is not easy to implement. You can write this thing. Okay, I will show you an example. I have example before, prepared before. Okay, it's a kind of a code, long method. Here we have. This is something that created our experiment before. So this kind of code is taken a normal text and obfuscated in almost non-readable way. So of course, this is an example of a code that is very difficult to read. So first thing, we try to understand, we try to read it, and we add some comments. So we have an idea to introduce a compose method. So this is written in the comment. We have a small manager class name, so we write this. We have a helper. Helper may be considered as an anti-pattern, so it's here, it's written here. There are some notes about names, about, for example, here we've got many invocations in one shot. So the matter law is broken. So here you can see examples of these things. This is, as I said before, just for better understand, just to make more clear in your head what you think, what you find in this code. And you can also do some, if it's worth, you can do some cleanup. Just maybe introduce better naming in this part when you are sure that that you understand it pretty well. Yes, so we have some constants introduced here, changed names. Oh, there's no shortcuts here. Oh, this is some kind of, the matter law that was broken is here, changed in some way. Okay, this is some kind of little cleanup. This is not a big refactoring. In Java, it can be done with automated refactorings. Okay. Okay, so we are here. This is the next step. We try to express refactoring. Almost every method, no matter how bad it's written, it has some structure. There is some kind of algorithms that we can express in a better way. And this is a point when we try to put these steps of algorithms that are in these methods, in this method, into another methods. We try to express algorithm here. So we use mostly the extract method refactoring here. We want to have a code that speaks to you. Compose method, sometimes we can introduce method object refactoring, extract method. Okay, in our code, yes, as you can see, during the analysis here, it was noticed that this part is about swapping neighbor words randomly. This part was about insert meaningless words randomly. Okay, this was concatenating everything. This was about removing punctuation marks. So we can see these are kind of steps of algorithms that we have here. So we can move the steps into methods, and the original one will look like this. Of course, this example is simple. In the production code, this step is not usually so easy like here, but it's just for having some kind of idea what we are doing here. So we try to put our code into some kind of steps. Okay, another step forward is when we started to extract the methods, we start to have many private methods. So it also can be some kind of a smell. But when you have many private methods, the next step you can do is to move these methods to another classes. Just using the responsibility principle, single responsibility principle. So find better places for private methods. So move these methods around. And this is what we can do in the next step. Okay. Single responsibility principle, move method refactoring, extra class refactoring, and so on and so on. And the next step that can be done or not, depending on the situation. When we move around these methods, we can find some kind of repeatable patterns, or we can find out that, that we need some kind of flexibility. And when it is about flexibility, the design patterns are something that you can take into consideration. So the next step is to maybe it's worth to introduce some kind of design pattern. But this is an optional step. You have to be sure that you want to do it. Because design patterns, architectural patterns, add some complexity. And we don't want to add complexity when it's not needed. So we have to be sure that we want to apply design pattern. In our code, we just moved this method, this private methods to another class. And these methods are kind of transformations that are done with text. And when we will look at this, maybe if you are very familiar with design patterns, maybe you can find that, okay, maybe it's a kind of a builder. Or you can treat this transformation as decorations, and maybe it can be decorator. Of course, the question is whether we really need it. But this is a question we can ask. And maybe introduce the pattern. Yes, but we have to be sure that we need flexibility. And the last thing, the last step is that we may want to introduce some architectural pattern. So maybe we find that the structure we have in our application is not good enough. I had one situation when team in some moment realized that what they program is more a state machine than some kind of algorithmic process. So it was a very difficult and time-consuming decision, but they decided to move architecture toward the state machine idea. So this is a very big thing. So this is one of the last steps in this process. And it's always a strategic decision. So any architectural changes just match here, introducing some kind of architectural idea, introducing layer, removing layer, and so on, just match here. And here we have everything put on one picture. All of the steps that I talked about before. We start from the first legacy solution. We do some cleaning and trying to understand what's going on. Then we try to express algorithm and moving methods and extracting methods. Then we try to, using the single responsibility principle, we try to move these methods to better classes. Then when we need flexibility, we can introduce design patterns. And when we need some architectural changes, we introduce architectural patterns or architectural concept. And this is something that should be done all the time. This is some kind of the process. So some pieces of code maybe need this everything from the beginning, and some pieces of code maybe are somewhere farther in this path, and we start from another place. And of course, this is only a kind of a model. So this is kind of an idea that it's helpful to have in mind. And of course, it's not necessary to follow exactly the steps, but especially for at the beginning, and especially when we have many junior programmers, it's much more easy to explain how we can do it, how we can approach the problem in such steps than just counting that they will do it by themselves. And the last thing that I would like to tell you is, where is the edge or the border? This is not the edge, it's fluent in some way, between the everyday refactoring and strategic refactoring. Yes, so cleaning up, extracting methods, moving methods, this is everyday refactoring. It's something that in most cases, we can do quite safely all the time. But those things here, architectural changes, design changes, design patterns many times are more complex, and this is something that we have to organize with the team and not do just because I have such kind of an idea. Okay, and that's almost everything. It's just a model. It's not a silver bullet. It's something that it's good to have in mind, just to be able to do refactorings in small steps, in more evolutionary way than revolutionary way. Some fragments of code may be at different stages of this model. Most legacy code would be very improved if we only just put this code into the phase that was called here compose method. It would be a big game changer for almost every legacy code. We don't have to move to the later stages. This would be good enough. As you could see, all these steps are they are done less frequently when they are these things that are in everyday refactoring we do more frequently than those things. Okay. And of course, because this is the kind of evolutionary approach, and in order to have to be successful in this approach, we have to have a vision. So we can do evolutionary changes when we have a clear vision about our architecture. We know what we want to have at the end, and then these changes can be done with more awareness. Okay, because lack of the vision may put you to local optimum that may be very difficult to get out. And this is Natural Course of Refactoring is a kind of ongoing process, and it's very helpful to have this as a part of developing process. In a team, it's easy to teach. It's quite easy to understand and remember, and to convey the knowledge about refactoring to younger, especially to younger programmers in a team. Separates or defines everyday refactoring and strategic refactoring, so it's easier to decide whether I have to have an agreement of the T to do something, or maybe I can do it by myself. And it can be some kind of a cheat sheet. What is the simplest step that I can do with my code at the moment? So not to do a very big change, but a single step that will improve a little bit the code we work with. And of course, it gives some hints what kind of refactorings we can do. Okay, that's all about the subject. I didn't talk here about testing, because testing is a separate subject, and it would be very difficult to combine it together. But there's assumption that there is some kind of testing process going with this.
So, are there any questions?
Nice talk, Mariusz. Question, have you ever measured the difference between the first version of the program, for example, you show us, and program which should be written in the best quality code way? So is there a difference between, let's say, bad code writing style in a time difference, or
is there a difference?
Yes, talking about time. Because actually, usual people, when creating crappy code, very in a hurry or in a rush. Usually, it's okay. I am missing the point. They don't know how to write clean code, for example. But what about they know?
If they know,
yeah.
What to do then?
No. The question is the difference between writing crappy code in time and very clean code. Is there any or no?
I see. I'm afraid that I still don't understand the question.
Is there a difference in the time it takes to write crappy code and really, really clean, nice code? Did I understand it correctly?
I'm not sure whether I can tell whether I have any evidences. It's my just opinion that I think and I believe that it's better to write and change well-written code. And this experiment I showed you at the beginning it's a kind of experience that shows us how difficult it's how more time it takes to work with something that is messy than when we have a clear structure in our code. But I don't have any scientific proofs for that.
Any more questions? Yes.
How much do you estimate for refactoring compared to the coding? So how many time do you dedicate proportionally for each of those activities?
Okay, it's always dependent on the situation or the team and so on. Because sometimes I have some kind of projects that the architecture is so messy that it's almost a business problem. And in those situations, maybe 80% of time is the time that we need to spend it. When it's more evolutionary change, I suggest to start about 15–20% time just doing refactoring. Of course, I talk about strategic refactoring, because this everyday refactoring is something that should be embedded in everyday programming. So this is, in my opinion, this is a part of programming. When I estimate time, how much time the task will take for me, I think about refactoring also when I estimate the time. So when we talk about strategic refactoring, so I would begin from 20%. But it depends on the state of the system and what kind of problems we have with this. Maybe we have messy system, but we can live with this, and there is not such a big problem with for the business, for example. And then it may be difficult to convince somebody in the business that we should spend more time on this. So, depending on context, of course.
Can we make some rule that if it is everyday refactoring, you don't need to create a separate user story, but then you plan to strategic refactoring, then you have to plan a whole sprint or some user stories for that, yes, and estimate them?
Yes, this is kind of thinking I use when I work with team. So everyday refactoring is something that we don't need to plan. It's part of a single task. But strategic refactoring is something that we have to agree when we plan the iteration, sprint, or release, or something like this.
We still have time for one more question.
Are there any signs when to stop refactoring? Because refactor is a kind of process which can last forever.
For me, this division between everyday refactoring and strategic refactoring is a stop. So start doing everyday refactoring and stop doing strategic refactoring unless you are very, very convinced that you have to do it. This is the way I approach this thing.